Hello everyone, welcome to Tech Show, and we are continuing our third part of mallet tutorial. In the previous two parts we have gone through how we can implement mallet using command prompt and how we can use mallet in using in Java. So if you haven't gone through all those videos, please go through for covering up the basics and then come up here. In this tutorial it will be a very short video because of I have already coded, and it was just I'll walk you through every single file, and you can find this code in my Git repository. So feel free to go and check out that code. Let's get started. So this is our project that we have created in the previous video. I have just added this mallet classifier class where I have put my pipe building code here, and how we are saving the classifier and how we are loading the classifier as well, and all those general purpose code that can be required for classifying the mallet can be put here. You can also use util directory as well, so whatever you can feel comfortable. So basically I have put all we are building a pipe over here, then we are saving the classifier and the pipe here. So it must be noted that we are saving both the classifier or the model and the pipe so as to classify all the tests data using the same pre-processing method and the same model. Then we have a method to load those classifier from that particular location, and the classifier can be saved in it as a serializable file. So we had used this object input stream to convert it into a serializable file, and then it's the same code that we had used for reading the directories in our previous video. So here is the controller class through which we are in which we are creating our APIs. So the first API is for training the classifier, and the second API is for testing our model. So as I have previously mentioned that everything is an instance, and it requires instance list and pipe to create a model. So here we are doing the same thing, that we are giving our input folder path, and it will take all the files from that folder, and it will create a pipe, then provide that pipeline and the data to create those instance list, and we are creating a new bias classifier, and we are providing it to the model, and we are giving the instance list, and it will save both the classifier and the pipe using this save classifier method that we mentioned earlier, and it will just provide a response as done, and that's it. So let's check how our training works. So we are waiting for our Spring Boot application to get started. Yeah, so it started, and let's check how it is trained. So as you can see that it's going through all those files, and you can see that our model is saved and our pipe is saved also, and you can check it in your resources directory that you have had the model and the pipeline serializable file is there. So to test our model, we are taking each and every file from test folder into a string, and we are replacing all the high-end ASCII characters here, and then we are loading both the classifier and the pipe. So we had created a method of getting classifier and pipe, so once we have loaded the classifier and the pipe, it won't get loaded again and again for each and every classification purpose. So then we are passing this string into an instance. So as we know, everything is an instance, so we need to create the instance and then pass this instance into an instance list, and then we'll pass the model and the instance list into this trial, and we'll get the prediction here using the getting the best label method of the trial, and we are returning the prediction. In the second API, we are using the same thing as we have used for the training purpose. We are iterating through each and every folder and the files. The other thing is that we have just created a code for creating the confusion matrix, and we are using this classify method to classify our data point, and we'll just use this code for creating the confusion matrix for it. So let's check how our test works here. So as we can see, our model has started to classify each and every text. So now our classification is done, and we can see that its results are good. Just the two that have been misclassified from the cricket class, as you can see. You can create different confusion matrix. It's just for the demo purpose, and I have kept it short because all those concepts have been mentioned in the previous video, and this is just to give you an impression that how we can use it to creating the APIs through which we can classify each and every points in an industrial purpose.